Okay, so here is the 3D model for my handheld Raspberry Pi 02W handheld gaming system. And let's start on the inside, right? So we'll get rid of that, and we'll get rid of the back cover and the robot. And this is the inside. This is the guts of the case, right? And this is the LCD screen. And if I get rid of that, we can see a little better. Inside here, this is a Raspberry Pi 3B Plus model that I downloaded from the internet. And when I first started this, that was the board I was going to go with. However, that board draws a lot of power, so it's not great for handhold running off a battery. So I switched to the Raspberry Pi 02W. The problem is there aren't a lot of inputs on that. And if you add boards on top of it, everything gets really, really thick. And I was trying to keep it as small and as tight as I could. And I did not know how to solve this until I came along this. Now this is a board I found on AliExpress. This part right here, the Raspberry Pi clips into, and it gives you all these USB ports and the network port, which I didn't really need, but it gives you all the ports that you would normally have on, a 3B Plus or a 4 or 5 or whatever. And this pretty much solved that problem. I got the lower power board, I got the inputs that I needed, and I was good to go. Sorta. The problem that I then had was inputs, right? I needed buttons. You can't play video games without buttons. And the first thought was I was going to try a cheap controller that I got off of AliExpress, and I was going to take out the board and I was going to use the guts for this and then just plug it in to a USB port. That did not work. Those cheap controllers are just what they sound like. They're cheap controllers and crap. And it lasted me not even a couple of weeks before the buttons started to fail. So that was no good. Then I tried using the GPIO pins, and I know this is mainly a modeling channel, so this part may not be interesting to you, but just try and stick through it. The problem was, I was building this mainly for two programs, the Dirty Wave M8 Headless and LSDJ. And while the GPIO pin button board worked with LSDJ, it did not work with the Dirty Wave M8, which that software actually sits on a teensy 4.1 board that you connect to the USB, and there's like a little ROM inside RetroPie that connects with the board and runs the software. That didn't work with the GPIO pin, so I had to eventually. I decided to make my own button board, right? And this is a Arduino Pro Micro, and I created a circuit board, and I got some buttons off of AliExpress, and I thought I was good to go. There are issues with that I'll get to in a little bit. The third thing was battery life, right? I originally had a smaller battery in here, and this is to stand in place of my battery. It's fairly large. The problem is, now I needed to charge that, and the little charging board I had wasn't big enough. So I got this off of AliExpress, and it's basically a charging board used for like battery backups. And this worked great. I just connected my battery in. I had USB ports that I could connect out, and it gave me a digital readout of, how much power I had left, and that was great. There's even a little button here that would pop up the display and let me know how much power I had left, rather. So that was solved. Now this is actually the second version of this case. Whoops. The original case, right, I had two much larger speakers off to the side here, and it was just too big. I still have the case because I really liked it anyway, and maybe I'll toss a picture up over here for you can see it. But it was just too big and too bulky. So I originally redesigned it. I found these little box speakers. They come in their own little box, and they worked out much better. So let's go back here. So now I have my speakers, I had my charger board, I had all the works going. So we start on the case. Now I wish I could show you a time lapse of this case, but this was not a 15-minute model job. This took me like weeks and weeks and weeks, and everything had to be measured and fit just right. And each time I added or removed something, I had to, you know, fix it for that. And so I eventually started to do was I just used the knife tool, and I cut in whatever I needed. See, this here is for the button board, and these are for the button boards to lean against, so nothing moves around on the inside. And it was quite a job. And in fact, here, remember that board I told you, that button I told you on the charger, right? This little button here that would give you the display to show you how much power you had left. Okay, right over here, zoom in a little bit, you see this little lever here. Now I created this channel straight through, and this little part here, this would surround the button, and there's a little bitty plunger here on the end that would press the button. All of this kept it straight so it could only move back and forth, right? Now that would press it and give me how much I had left, and it was really useful, so I wanted to include that. Plus, I can't seem but to help make the project the most complex way humanly possible. I seem to enjoy that a lot. And this basically started out as a box, right? It started out as a cube that I just kept adding to, and oh, it would be a little great if I could do these little features here. It would give it some interest up on the top, and we want to match that down on the bottom. And then, oh, what if I made it look like our spaceship? That would be kind of cool, right? So I added these little thrusters down here on the bottom, and if you look, there's like little, stuff in here that looks like pipes that deliver the fuel or something like that. And on the side here, on the other side here, this is the little port that would charge it. And if you look at the guts, let's go back to the guts for a second. You look at the guts right here. This is a cable that I bought that goes up to the battery charger and will recharge the battery. And literally, you'll see that goes right underneath the, and it's much tighter than it looks. So everything was like really, really tight and difficult to arrange, and it took me forever to work this all out. And there was a lot of problems to solve, and I had to figure it all out, and it was tough. So that's the front of the case, basically. Now the back here. So I wanted something fun on the back, and I was basically planning on using this, like I said, mostly for music creation, for LSDJ, which is a music tracker, and the MA Dirty Wave tracker, which is another music tracker. And you can look either one of those up here on YouTube. There are a ton of videos on both. LSDJ is used primarily to make chiptune music, and the M8 has a little more versatility because not only can it do chiptune stuff, but it can also do like synthesizer stuff. It has its own built-in little synths. So I wanted to put something on the back that kind of showed that, and this is my like little cosmic DJ girl here. And all of these little pieces, they're meant to be like sound waves, and they're all separate. So I hand model all of these separate, and I spent like who knows how long getting all of these little channels perfectly even. And then when I printed all of these things out, I used double stick tape to put them down on cardboard, and I airbrushed with mica paints to make it look sparkly. And once again, maybe I'll stick another cover, a picture of the back there so you get a better idea of what I'm talking about. And Robot Girl here, she was a lot of fun. Here, I'll give you a better glimpse of her. Okay, here is Robot Girl, and this is all subsurfed, right? All of these parts were done separately, and had to be joined in together to make one solid thing because I printed her separately, right? If we go back to the case, on the back side, let's get rid of the guts and the case because this file is huge. It's like over 2 gigs, so it makes it really hard to deal with. But you see what I did? After I finished modeling her, I used a Boolean operation to cut her back flat, and then I put holes in her, consigning with pegs, and there's even pegs in here, so that she would be held firmly on, right? So she wouldn't fall off. I don't trust glue by itself. Like if you take two flat pieces of resin or even filament printed 3D prints and just stick them together with some epoxy or super glue, I found to even be weaker over time. Like initially it sticks well, but weeks down the road, if you look at it funny, it'll fall apart. Even with a two-part epoxy, which is my preferred way to put things together, I use Z-epoxy. I prefer there be like some kind of mechanical connection as well. That's why these posts here help, stick her on, help with the mechanical lock as well as the adhesive lock to hold everything together. I learned a lot from this project, right? Dealing with the electronics, I created my own circuit board for these button things. There was a lot of work that went into this, and cutting the buttons, the holes for these buttons, because I handmade the circuit board. I didn't use like some computerized process. I drew the circuit traces with Inkscape. And so nothing was really 100% perfect. Like I could set these buttons up perfectly in Blender, but as a human, even when you solder things on, sometimes they're a tiny bit crooked. So what I had to do was I created a plate that I Booleaned holes in and printed that out and then matched it up with the button board to see if it fit well. It was a lot of adjusting and a lot of crazy stuff to do. And ultimately, even though it was a great project and I'm happy with the way it came out, I'm going to take it all apart. The problem is, one, it's huge. And just because of the software and the hardware that I had, I couldn't make it any smaller. And it's heavy. I'm sure the big battery has a lot to do with that, but even without the battery, it's still big and heavy. And, this was my first big fancy case. I made these sharp edges. These are all 90-degree angles, and it's uncomfortable to hold. Combine that with the heaviness, it's just not comfortable to hold. And lastly, it didn't really run that great. I could run Tetris fine. It ran Tetris fine. I played it once for I don't know how long, but LSDJ and the M8 software did not run well. Now, when I did this, I think it was still the first iteration of the Dirty Wave M8, and now I think I used version 2 point something of the software, and now they're up to 6. So this was a long time ago already. So maybe that had something to do with it. Maybe the Raspberry Pi was just not quite fast enough to handle it. I don't know. I found that the synths in the Dirty Wave M8 would crash on me a lot, and it was sort of a hassle. And another issue I had was with buttons. Like one button press in LSDJ would send the cursor 5 spaces over. And it's really frustrating if you just need to move one spot over to adjust something or to create a new track or something, and you shoot halfway over to the other side of the screen and you can't get it to go back to that one spot. I had that a little bit with the M8 software, but not as much. So in the end, it's just really not as usable as I want it to be. So I'm going to end up taking it apart. I wanted to document it a little bit because I did put a lot of work into this, and I just wanted to show off a little bit. Because even though it's not really 100% success, I think it was a great project and a great learning experience and a lot of fun to do. Like I said, I love complicated projects. I love figuring my way out of a spot that I got myself into somehow. And this was definitely that. So I'm going to take the 02W out, and I think I'm going to use it for Octoprint. And then I'm going to take the Teensy, which is what the M8 runs on. Right? Go back to the guts. Right here you can see the Teensy. Oh, actually, wait. This is part of the guts. And here you can see the Teensy and how it was connected by a USB board. I mean a USB cable. And I had to hand make these cables because the problem with a lot of the cables, like this is a bought cable, they all come with these big, chunky, hard things that make it very difficult to do tight, small things. So I had to hand make my own cable. I did it here as well. You can see that's a handmade cable. I think that plugs in here to power the Raspberry Pi 2W, Raspberry Pi Zero 2W. But that's just kind of what it looks like on the inside. I know it's sort of hard to get an idea of what it's like from this. And maybe when I take it apart, I'll make a video and I'll let you show the actual guts. The problem is, anytime I take that thing apart, no matter how well I do the soldering job, you wiggle those wires twice and the connection breaks, and then you got to figure out how to reconnect it and where the broken wire came from. It's a pain in the butt. I swore to myself if I put this thing together, I'd never take it apart, but I don't plan on putting it back together. So, I mean, it's a little sad. All of this stuff is, I'm going to have to find something to do with this battery and the charger and the screen. They're all great sizes. I mean, they're all great, parts. I'd hate to see them go to waste, so I definitely want to come up with something like that. At one point, there's a couple of guys who made like a Game Boy with I think of a Raspberry Pi Pico, and they could hand code their own games, which I've always wanted to learn how to code. So maybe I'll look into that. I don't know, but I just wanted to document this a little bit because I did put a lot of work into it, and I really, even though technically it's not good for what I wanted it to be used for, I still think it was a good learning experience. It taught me a lot about creating a case like this, about printing a case like this, because even though I have a Saturn S, this pretty much pushed the limits of what the Saturn S can print. It's pretty big. I think that there might have been like a half an inch on the bottom. Because I couldn't even print this straight. I printed it on a little bit of an angle, and that's basically for resin printing. Things print better on a bit of an angle anyway, so that wasn't a big deal. But I just wanted to document this just a little bit. It was a good effort, and it did come out, and I was proud I got it working. But it turned out to be not the greatest handheld, because it just didn't run very smoothly. Maybe there's a newer retro version of RetroPie that would run it better. I don't know. Maybe it was a lot of things. I am not an electronic expert. I know just enough to get myself in trouble. So maybe that's what I did here. Who can say? But it was a fun project, and I just wanted to document it a little bit. I'm gonna create a case for the Teensy. I'm going to put that on an Anbernic handheld device, which is supposed to work much better. If you look around on YouTube, you'll see there are tons of people doing that. So I'm going to give that a try and see if that works better with the Dirty Wave. And maybe I'll do a little bit of a video on that, because I found an interesting thing. Some guy did a case, and there's a little USB hub board that he was able to stick in there. So I'm going to give that a try and see if I can get it in, and as well as make the SD card accessible and all sorts of things. So that's the end for this guy. And it's quite sad. But I'm going to keep this back piece. I really like the way this back came out. She came out really good. She's a nice character, and the airbrushing, which I had never really done. I had messed around a little bit in high school, but I'm not a big airbrush guy. It's an annoying tool sometimes, but it's great for doing little paint jobs, and I got some really nice gradations in there with the mica paint, and it came out really nice, so I was really happy about that. So that's my unfortunate tale about the Raspberry Pi handheld that just sort of didn't work out the way I thought it would.